Afternoon? So that should keep things a little quicker. I'm just going to jump right into it today. So basically, when you have a sphere, and if you have a sphere with the same radius as a cylinder, okay, same radius as cylinder, and its height is same as like the diameter of the sphere. So this sphere, imagine that this is actually touching right at the bottom and right at the top, the center. Okay, so it is the same dimensions, except for one's a cylinder, one's a sphere. Okay, we're not going to prove this today, but the volume of a sphere is 2/3 the volume of a cylinder. So if you took the volume and you fill it up, it would fill up 2/3. So one thing you could do if you had that same sphere and you had that same cylinder with the dimensions, you would need how many to make the same? Okay, so if I had 2 cylinders, 2/3, yeah, you could do it. Okay, you could prove it if you had 2 cylinders with the same dimensions, that when you fill it up, you need, yeah, because 2/3 of the first one, so you do this 3 times, 2/3 of the second one, and then 2/3 of the third. I'm not doing a good job. Sorry. So here is this. Oh, that's my cylinder. Okay, 2 cylinders with the same dimensions. So if you pour first the first dump in, it would fill up 2/3. Okay. Now I pour it again until it's full. So it would fill up 1/3 and then 1/3. And then I pour it again. So with 1, 2, 3 pours, it would fill up 2 cylinders. Okay, so that's basically what it would do if we wanted to prove it. So how do we get our formula? Well, formula for volume of a cylinder is pi r squared h. So 2/3 pi r squared h. I am like rushing a little bit. I'm sorry. So, but with our sphere, do we have a height? Well, it's the diameter, right? The height of a sphere is the same thing as the diameter, or 2 times the radius. And so when you have the height, we're going to sub you have your radius squared. I don't like this example. Let's go over here to this one here. So our height is 2 times the radius because that's the diameter, right? This height is same thing as the diameter of the sphere, which is 2r, right? 2 times the radius. Everyone knows that from a circle? So when I sub that in, you have pi times your radius squared times 2r. Your height is 2r. So we're going to simplify this formula. So what happens? So let's put the coefficients together. I have 2/3 and times what other coefficient is there? Pi we're going to leave separate. What's the other one? Is there another number there? There's a 2, right? So 2/3 times the 2. I'm just going to move that out front. There's pi, and then there was an r squared and an r. So what does that simplify? 4/3. 2/3 times 2, 2/1 is the same thing as 4/3, right? We go straight across with fractions. So 4/3 pi, and then if you have r squared times r cubed. So that's the volume. That's the formula for the volume of a sphere. That's how it's developed. It's from the volume of a cylinder. We know that it fills up 2/3 of the volume of a cylinder. Okay? Do you need to memorize that or figure that out in the future? No. We're just quickly going through it. You should see what I'm doing here, right? This was r squared. So we had an r squared times an r is how we got the r cubed. And we had 2 times 2/3, which is how we got 4/3. Okay? And then pi. So that's our formula for a sphere. For the surface area, sorry, the volume of a sphere. Surface area, I'm just going to give it to you. So you can prove it like with oranges. So if you take an orange, preferably a very circular one, and you measure its diameter or radius, diameter, so you can easily figure out its circumference, divide it by pi, and then you have its diameter. You draw 4 circles, and you peel the orange, small little pieces, and it fills up 4, because look at this formula, 4 pi r squared. So if you have an orange or anything that's circular, so here's my sphere. So if it has the same radius, we can draw the area of 4 circles with the same radius has the same surface area as the sphere with the same radius. Okay? So we're going to talk about hemispheres as well, really quickly. So a semicircle is half of a circle, right? So a hemisphere is half of a sphere. So if we take our sphere and we cut it in half. I should go grab it. An orange? Do you guys all want oranges? Yes. Should have brought a board. Okay, so the volume of a hemisphere, we said, is half of the sphere, which is 2/3 pi r cubed. Because the sphere is 4/3, half of 4/3 is 2/3. And then the hemisphere was the curved surface. So what did we say the curved surface was? 2 pi r squared. Plus the area of the circle base, which was pi r squared, which is how we got 3 pi r squared. If the base is not included, what would be the surface area of the hemisphere? We do not include that extra base of a circle. Yeah, 2 pi r squared. It would just be half of the sphere. So that we would use that as in an example. Say I had an ice cream cone, right? We don't need the base. We just need the ice cream part, top exposed surface. Okay, so let's go through some examples. Oh, do I want to do that one? No, we're skipping example 2. Let's go on to 3. Candy used a rope to wrap the outer edge of a beach ball exactly once. So she has this beautiful beach ball. Sort of. That's not right. Something like that. Okay, so there's her beach ball. Not that colors matter, but they're way more fun. It's good? Okay, good. So if I take and I wrap a rope around the outer edge, think very hard of what that's called. The outer edge around the ball. Circumference. Yes, it is your circumference. The rope is wrapping around the ball. That's our circumference. And she measures that distance around the ball to be 108. So the circumference is 108. Determine the volume to the nearest tenth. So what's the formula for the volume of a sphere, first of all? 4/3 pi r cubed for volume. That's on your formula sheet. So if our volume is 4/3 pi r cubed, that means I just need to know which value. The radius. And how do I get the radius? I think it's on your formula sheet. It sure is. Look on your formula sheet near the circles up at top. Circumference is equal to 2 pi r or pi d. Up to you which one you use. I'm going to use 2 pi r. Okay? So I'm looking for radius. That's what we're going to do. We're going to use the circumference formula because we know the circumference to find out the radius. Okay? No? I missed that. Sorry. Because we know the circumference. Right? You could use pi d and then find the diameter and divide it by 2. Same thing. Okay, so 108 is equal to 2 pi r. What do we have to do? Yeah, opposite operation, so divide by 2 pi. What does your calculator need? Brackets, thank you. If you're dividing by more than one thing ever, it's more than a monomial, you need 2 pi d. So it was 108 divided by 2. Oh, see, this is wrong. That's what you don't want to do. What you want is a bracket 2 pi. So that's the nice thing about finding the diameter. You're just dividing by pi, and then you're less likely to make that mistake. 17.1887 approximately. Okay. Now when I plug this in, I might write 17.2 even, but in my calculator, what do I have to use? The exact value. Okay, we have to use the exact value. So one way on your calculator to do this is we're plugging in 4/3 pi. And then one thing you can also do, most versions, if you have a silver, you can go up here and it'll highlight that number and push enter. So whatever number you wanted. And then power of 3. Okay. You could have also done 4/3 pi. How do I get previous answer? Second negative to the power of 3. Okay, that would work too. Did you get the same thing? Yeah? Okay, good. So to the nearest, what was it? 10th? 21,272.6 centimeters cubed. Two more examples. Aren't we doing much better than yesterday? For time? Yes.
Yeah,
much better. Okay, Dana and Don are constructing dome tents in the shape of hemispheres. Yay! Uh-oh. Is there something? Okay, so Dana's tent, did you draw it? Dana's tent has a diameter of 4 pi. 4 pi is the, diameter. Let's draw this again. Almost put radius. Diameter. So this length across is 4 pi. Should I make it larger? Here. There we go. That's better. Dana's tent has a diameter of 4 pi and will have a base made of the same material. Don's tent also has a diameter of 4 pi, but he chose not to construct a base. Okay, so one has a base, one doesn't. Calculate in terms of pi how much material Dana needs. So the surface area for Dana, does she need the floor? Yes, so Dana needs the base included. So with base included, what would be the formula for surface area here? Two pi r squared plus pi r squared. So that would actually equal how many pi r squareds? 3 pi r squared. Do we know the radius? What is the radius? 2 pi. So if the diameter is 4 pi, half of that would be 2 pi. Everyone agree with that? So because this was diameter, so half of 4 pi, if you take 4 pi divided by 2, it's 2 pi. If you have 4 x's and you divide that by 2, it would be 2 x's. Cut it in half. Okay? All right, so let's plug this in. surface area equals 3 times pi times the radius is 2 pi all squared. We're going back to our exponent laws here. Because when we're squaring 2 pi, we have to remember to square who? Everything inside. The 2 and the pi. Right? This is back to exponents last unit. So this is the same thing as 2 squared times pi squared. We're squaring both of them. We're bringing the power 2 into both. What is 2 squared? 4. So what can I multiply the 4 with? 3. What's that equal? 12. So that'd be 12. Because 3 times 2 squared, or 3 times 4, is 12. Okay, pi times pi squared. Pi cubed. Oops, that's not right. Pi to the power of 3. See, in high school math, we want to leave things as exact values. We don't actually want to type it into our calculator often. Okay, so did I lose any of you? No. Are you okay? So I multiplied 3 times 2 squared. I underlined them in black. 3 times 4 is 12. Pi times pi squared, exponent laws. Same base as being multiplied, we add the exponents. So the exponent of pi, if you don't see it, is a 1. 1 plus a 2 gives you 3. Do we ever actually type that in? Like evaluate? Yeah. This one, they want it in terms of pi. So that's why they said it's a pi. That means they don't actually want you to evaluate the pi. Okay. Then you would actually type it in. Yeah. Hey, this guy. John. Base included or not included? No base. So what would be the formula of the hemisphere with no base? 2 pi r squared. 2 pi r squared. I do not need to add the extra pi r squared on the bottom. 2 pi times, what's the radius? 2 pi to the power of 2. So when I square 2 pi, what does that become? 4 pi squared. Right. Because 2 pi, whoa, let's try that again. Try that again. There we go. So if you have 2 pi all squared, you're applying the square to both of them. So 2 squared and pi squared. 2 squared is 4. That's how we got that. Okay? So collecting like terms. What's the new coefficient going to be? 2 times 4 is 8. Pi times pi squared? Pi cubed. All right. Okay? No. Yeah? Oh. The hemispheres. So, like this. So, with base, no base. Right? And then same with volume. Well, the volume's easy because you can find the volume of sphere and just divide it by 2. So the volume's no stress. Because you're not adding in extra shapes, right? With the volume. Volume, you're literally cutting the sphere volume in half. So find the volume of a full sphere, divide it by 2, you got it. Or use 2/3. Okay? The volume of a basketball. What shape is a basketball? It's also a sphere. Close enough. Okay, so it's a sphere. What is the formula for the volume of a sphere? 4/3 pi r cubed. It said determine the radius. Okay, let's sub in what we know. What do we know? Just the volume. The volume is 433.5. No, 430, yeah, it is. 433.5. Now we have to do some math. There's a couple ways we can isolate, like get rid of the 4/3. What's one way? Okay, so you could divide both sides by what, specifically? 4/3 pi. So you can do that. Divide both sides by 4/3 pi. You just need to remember what in your calculator? Brackets. Okay, I'll show you how to isolate r first, or like after we finish the question. I'll show you another way after. So in your calculators, my thing is this goes to sleep. Gotta figure out the settings so it doesn't go to sleep. Okay, so what are we doing? We're doing 433.5. Nope, I missed a 3. Divided by bracket 4 divided by 3 and pi bracket. So 4/3 pi. Which gives you, you get the same thing? As long as you have brackets, 103.49. Okay. So that's 103.49 equals what? What's left over? R cubed, so cube root. Opposite operation up to power 3 is the cube root of both sides. Okay, so cube root of this number, math number 4. And then if you want, you can just highlight that and push enter if you have a new version, or second negative for answer. 4.69. Okay, to the nearest centimeter, that would be, oh, I don't know why, 5 centimeters. Okay, really quickly, if I wanted to isolate r first and then sub it in, what I would want to do is get rid of the 3 first. So I would, how do I get rid of the, it's being divided by 3, I'm going to multiply both sides by 3 is what I would do first. Okay, so now you have 3v's equals 4 pi r cubed. Now I would divide it by 4 and pi, and they'd be in brackets in your calculator. And then last, you have 3v over 4 pi equals r cubed. Cube root that. Cubic root. So 3v over 4 pi. So I'll just show you, you can isolate it first. That's what you would do in physics, right? So math 4, cubic root of 3 times your volume, which was how much? How much was your volume? 433.5 divided by bracket 4 pi. So it can be done all in once. Okay? Physics, science, if you're planning on going to physics, you want to practice that. Okay? So if you are, that's something you'd want to do. Math, we sub in, then we isolate. Okay? Which is kind of nicer. So we're done. Assignment. Circle the following, okay? First one, A, B, and D. 1A, B, and D. I'll write it on the board after. Number 2, A, B, and D. A, B, and D. And then number 2, all of it. All of 3. Turn the page. No 4. You can do number 5. No 6. And then 7 to 10. 7 to 10. And 10. 14 is optional. Okay? So this one is optional. Okay?
So, aren't you supposed to use the asterisk if they got 4.7 instead of 4.6?
What do you mean answer? I did. I used the previous answer right here.
And you got 4.6?
Yeah.
The same thing I got.
Okay, I'll take a look at your calculator. Don't touch anything. Yeah? Oh no!
Oh, rest in peace. Oh,
Okay, example 5. Oops, why am I undoing? That's not what I want to do. I want to go back. Example 5, Miss Johnson. It said it was inches cubed, so you have to, it wants centimeters, so you just have one extra step. This is inches. How do I convert an inch to a centimeter? Times by what? 2.54 centimeters in 1 inch. So what does that give you? Previous answer times 2.54. That sound better? 11.9? Well, so the nearest then would be 12 centimeters. Good eye. Okay, I'm just going to stop this recording.